I think we're going to go ahead and get started here as folks are still rolling in. My name's Ben Snively. I'm a specialist solutions architect at AWS. I've been at AWS for about 3 years now, and I focus on the data and analytical services. So I work with customers that are adopting big data applications in the cloud and help them build the patterns solutions in AWS. In today's sessions, we're going to talk about serverless analytics and how serverless analytics could really help your big data application, how to streamline it, how to really drive insights as quickly as possible through your big data analytics. The format or the agenda that we're going to be going over is really what is serverless, why are we talking about serverless, and why do you care? How does that fit into big data applications? How can it really help expedite and really drive those insights very, very quickly? And going to include a set of demonstrations. So we're really going to show some design patterns of how to use these analytical services to be able to do things like real-time analytics, quick discovery of data, analysis of data, integrating things with Hadoop, that sort of thing. Out of curiosity, how many folks in the room have experience with some sort of serverless capability, Lambda, any of those? Awesome. So when we talk about serverless, we're really talking about an architectural pattern or an approach. And if we really look at how serverless analytics evolved, back in 2006, EC2 was launched, and that really launched virtualization within the cloud. So you're able to spin up EC2 instances very easily and focus above the OS and scale those servers very, very quickly. We have a set of managed services. So if you think of things like Redshift or EMR, very, very powerful services, but they're considered managed services. And the reason why that is you as a customer are still thinking about servers. Even though you're not managing them, you're thinking about servers saying, I want this big of a server, I want to auto scale based on these policies. So you're still thinking about servers as a unit. You're just not doing a lot of the undifferentiated heavy lifting of installing, patching, monitoring those servers that make up that cluster. With serverless, it's really a new pattern. So with serverless, you don't really think about servers at all. You can just focus on writing your code. That could be ETL code, pre-processing code, various capabilities like that. It could be SQL-based analytics, ETL, that sort of thing. And why that matters is, since you don't have to worry about servers yourself, you don't have to think about the scaling and the provisioning of those servers, the managing of those servers. The services scale per use. And because they're scaling per use, they're also charged based on execution time. So if I execute some code within Lambda, I'm charged for every 100 milliseconds of that execution time. If I'm actually doing ETL using Glue, I'm charged per minute of that ETL process as it's executing. So I'm never paying for idle. It's always charging based on the execution of me doing work, which is really, really powerful. And you don't have to worry about the availability and the fault tolerance. Those are all abstracted away within that managed service within the region. So how do these serverless capabilities really help augment your big data applications? And we're really going to go into a lot of depth here. One of the key takeaways I wanted everyone to see, though, is many of our customers are really mixing and matching these services. So you could very easily have a solution, a big data application, that pieces are running on EC2 in a virtualized environment. Some of it could be managed services, and then other pieces of that solution could be serverless capabilities. And towards the end, we're going to show a demonstration that actually brings some of those together. So you don't have to necessarily pick one. I only want virtualized, I only want managed, I only want serverless. You could have a hybrid or a mixed solution that brings in the right service for the right job. And we're really going to dive into some key services and some architectural approaches of using those. So how can I rapidly ingest data into my application? Making ingest within minutes or hours rather than days and weeks. How can I very easily transform my data? How can I query and analyze my data? So we're going to step through some of these services. It's going to be a very, very quick overview of what is Lambda, what is Glue, these sorts of things. But then we're really going to dive into these patterns during the session. So a lot of folks in the room raised their hand about what is Lambda or serverless or having serverless capabilities or experience. But Lambda is a service that is very, very powerful. What it allows you to do is upload your own custom code And that code is triggered based on a set of events. It could be real-time data coming in through something like a Kinesis stream to be able to very, very quickly process those streaming events. Or it could be more batch-oriented. You want to create a thumbnail based on an image coming in, or you want to do some processing of geospatial data. So all these are event-driven. It could be either a synchronous or asynchronous event. And you want to do some logic. So when you're writing Lambda, you write that piece of code that does that very specific logic, and the ecosystem or the platform handles all the rest in terms of notifying your code whenever that happens, being able to span across your AZs, that sort of thing. With Athena, and we're going to talk about how these are put together here in a moment, but with Athena, you're able to do SQL-based queries against your data. And the reason why this is important is in big data applications, oftentimes folks are doing what's called schema on read. What that means is you're saving your data first. It's a ELT methodology rather than ETL methodology. You save your data as quickly as possible, and then what you're doing is you're querying your data and you're applying the schema when you're executing against that query time. And what Athena allows you to do is very rapidly ingest your data and have that on S3, and then perform SQL-based queries against those data sets. So in big data applications, it's really great to be able to bring in new data sources, being able to analyze data, fuse data sets together, some of which might be different data sets. One might be JSON, another could be CSV, and bringing those data sets together. Another service we're going to dive into is AWS Glue. This is a service that really is made up of two key parts. The first is the data catalog. This data catalog is a Hive-compliant data catalog. It allows you to store your metadata about your data in things like your data lake on S3, or it might be data in databases or your data warehouse. And this catalog is really very nicely integrated with things like Hadoop and EMR, or Redshift Spectrum to be able to bring it into your data warehouse, or things like Athena, which we're going to demonstrate many of those today. The other piece is really being able to write serverless ETL. So under the covers, Glue uses PySpark. It uses Spark containers in order to execute your ETL logic. But within the Glue service, what you could do is you could build your ETL, or you could have your PySpark code already that you've developed that you want to execute. And you could execute that inside the Glue environment, and it'll spin up the cluster, it'll execute your job, you'll shut it down, and your data is saved out either into your database, data warehouse, or back to S3. Amazon Kinesis is really made up of a set of services. So Kinesis includes Kinesis Streams, which is the first service out of the suite that we released, which really allows you to very easily, rapidly ingest and scale real streaming data. So it's very easy to build custom applications in Spark, streaming, and Storm, and Flink, or use some services that we're going to demonstrate today using streams. Firehose allows you to really populate your data lake very easily based on streaming data. So let's say you really want to be able to collect clickstream data, or you want to collect data from IoT sensors or telemetry data, and store that data on S3 so you could do things like machine learning, deep learning, or maybe you want to build some analytics in Spark or Presto or various languages on the Hadoop ecosystem. You could use Firehose to very easily capture that. It'll store that data in S3, and then you can start analyzing it really, really easily. And we're going to demonstrate both Firehose, and the next service that we're going to talk about is Kinesis Analytics. Just like Athena provides SQL-based access to S3, Kinesis Analytics provides SQL-based access to streaming data. So the two use cases and how they differ is they're both SQL-based, but one is based on your data that's at rest on S3, and you want to analyze that large data sets. And Kinesis Analytics is SQL-based against your real-time data or your streaming data. So if you want to do sliding windows, tumbling windows, various filtering algorithms through SQL, you can very easily do that using Kinesis Analytics. So I promise now we're going to really dive into some of those architectural patterns. I wanted to set the stage for some of the folks that may not have heard of some of those services ahead of time. So how do we apply some of these to some of the serverless capabilities to these big data applications? If we take a look at the different big data applications, we have many on AWS. So you have things like data processing, data warehousing, reporting, artificial intelligence. So many of these applications have different requirements. So the way you do real-time analytics has much different requirements than how you do a batch analytic or business reporting. Because the way you acquire your data is different. If you have real-time data coming into, the constraints of that data source is different than if you're doing batch loads from your database or data warehouse and different data sets. But many of them do share a lot of the same characteristics. So you want to be able to collect data from many, many different data sources, depending on what application you're writing. You want to be able to dive into those data sources and analyze them with a very wide number of tools. You want to be able to access that data very flexibly, but also very securely. And the other really big thing, especially in the analytical space, is what we call future-proofing. So we like customers to be able to build these architectures that really lets them bring in new types of analytics very, very easily. So today it might be various sorts of machine learning and deep learning algorithms, but the type of analytics and algorithms you run a year from now might be very different. Maybe it's using FPGAs or different sorts of infrastructure to be able to very quickly analyze that data. So how can architectures be put together that gives you that decoupling, that nice architecture to be able to bring in these new analytics, but also very easy to iterate and develop? So if we take a look at the flow here, some main components of these big data applications, and we're going to start plugging in how these serverless analytics or serverless services really fit into these pipelines. The first is really how do you ingest and collect the data? And within there, we really have a couple different serverless category services that fall into that. There's really the Kinesis suite, very, very easy to be able to bring in new real-time data into your data set, into your application. And of course, S3. Hopefully, everyone in the room is familiar with S3 to be able to store your data. But once you have your data, you want to be able to very easily categorize and search that data. So at the New York Summit earlier this year, Glue went GA. And Glue has a really great capability to be able to have a metadata catalog. And we're going to demonstrate how this catalog really makes it easy to be able to bring in new data sets. Be able to maintain data sets so that if your data changes over time, your catalog gets up to date. And then also how that catalog could be integrated with really a wide set of tools, some serverless, but also others that may not be. Of course, as soon as you bring in your data, you may want to be able to transform your data, get the data into a canonical form, morph that data various ways. A couple different patterns that folks use in the serverless environment to do that. The first is AWS Lambda. So that allows you to very easily write transformation code to be able to transform your data. Most often, that's done with real-time data. So if I have various real-time data sources coming in, I want to write a transformation logic in Lambda. I could do that very easily. I write a few lines of code that transforms the data, and then it'll execute that as it's storing it out into the repository or running the analytics on that. But if I have large data sets, maybe I want to transform gigabytes, petabytes, terabytes, very, very large data sets that I want to run and do transformation on. AWS Glue is really the right choice there because it's very, very powerful to be able to write these transformations, run them in a serverless environment, and be able to save your data either back to your data lake on S3 or your data warehouse or your database. After you have your data transformed in a particular way, oftentimes you want to run analytics on that data. So Kinesis Analytics provides that SQL-based analytical capability on top of the streams. And then Amazon Athena provides that SQL-based access on top of your data stored on S3. What we're going to show a little bit also, though, is you could use many of these components. So you could use Kinesis Firehose. You could use the Glue data catalog. But you could very easily launch an EMR cluster and in a managed environment to run analytics and do things like graph analytics or machine learning using Spark or various tools out of the Hadoop ecosystem, but still leverage things like the Glue data catalog, ETL, that sort of thing. And then lastly, for visualization, we have many, many great partners in the BI space. We have a really fantastic product called Amazon QuickSight that lets you very easily plug in these data sources and drive BI dashboards on top of that data. So if we take a look at one of these threads through, and I promise I'm going to give a couple demonstrations here, so thanks for bearing with me, or demonstrations, I should say. But if we take a look at this flow here, this is a very, very common real-time analytical flow. So Kinesis, and I'm going to show this in a minute, very, very easy to stand up with a few clicks of a button and have a service that will capture your data sets in a very robust way. So what you could do is you could set up a Kinesis Firehose. You could instrument your various applications. So that might be a web application, a mobile application with some producer logic within there. And then you could capture all that information very, very quickly using Kinesis streams and Firehose. Lambda to be able to do transformation. So maybe different producers are producing the same data, but they call fields different names. And you want to get the data into a canonical form before you run your real-time analytics on it. Kinesis Analytics and then QuickSight to be able to visualize. So let's dive into a demonstration here real quick. So what we have here is a Kinesis Firehose. This is a Kinesis Firehose right here that I set up earlier this week. And what you'll notice is, as soon as I configure this Firehose, I configure a destination. I specified S3, but you can very easily specify S3, Amazon Elasticsearch, Redshift, multiple different destinations depending on where you want to store this real-time data. I specified S3 with a prefix of raw, because this is my raw data coming in. And what I'm demonstrating is a simulated messaging application. So what we're doing is we have instrumentation, theoretically. We actually have some agents that are publishing messages right now. But you can think of it use case-wise, many, many different messaging applications around the globe that are generating chat messages. And we want to capture all those messages and analyze the sentiment of what people are saying on those chat applications. So within here, we have this Kinesis Firehose. And this is actually, I just configure this. It's writing out to this S3 location. It's automatically saving the data, batching it up for me so that one S3 object contains multiple records, zipping it, very nice integration with KMS, all that important aspect. So if we take a look over here at what this data looks like, it actually, the data getting written out looks like this, and I'll make this bigger for folks. So this is just fake data. We have some generators that are generating fake messages with random words, that sort of thing. But this data is actually getting pushed out to the Kinesis Firehose automatically. We're having thousands and thousands of records per minute. It could scale much, much greater than that. But we are pumping data, decent data through it. It's not just a couple messages here and there. And what you'll notice is with Kinesis Firehose, it's automatically batching this data set up for me, saving it out to S3. And then if I want to run heuristical analysis on this, I could very easily query this data using Athena or EMR or various tools on top of it. Next, let's go ahead and let's say we want to analyze this data. So this data set actually has location information. So you'll notice a country designation of where the message is coming from, a lat long. It has a timestamp. It also has some derived fields that we're doing within Lambda, which I'll show in a minute. Let's say we wanted to analyze this data. What I'm going to show next here is Kinesis Analytics. So what we stood up here is we want to run real-time analytics of what the sentiment was, both positive and negative per country, of people talking on our messaging application. So I could have written this in Spark Streaming or Storm, or wrote my own KCL that read the data off, or do various methods. But I could very easily plug in Kinesis Analytics here as well. And you'll notice this SQL code is only I'll scroll down, but tens of lines of code. It's not hundreds of lines of code. So I could very easily write this SQL statement that does my real-time analytics, deploy it out, and start getting the results out very easily. So what this looks like here is this is actually defining the output here. The output contains the country, the lat, the long, and then really that sentiment count. So what we're doing is we're doing a sliding window counting what the positive and negative sentiments are per country. Since this is based on SQL here, This next section here is all I had to do to write to actually start generating that data. So I'm generated into the destination SQL stream, and I could just write my count negative, count positive, and then this is doing a 30-second window, counting the positive and negative sediments within the generated data. So over here, we can actually see some of the data coming in. This is actually live data that's getting generated from our simulator. Processing some of this. We can actually take a look at some of the real-time analytics that's generating. This is completely fake data. We're using a simulator to generate this, but it's real data. It's real messages going through Kinesis and being analyzed here. None of this is kind of staged in any way. But what's kind of interesting here is now what we can do is we can actually set up various destinations. So let's say we want to capture this and store this data out to S3 and then be able to integrate with other types of analytics in our big data application. What we specified here, this is the higher level definition of the streaming application in Kinesis Analytics. We were just in this portion here for the SQL results. We're reading off of that messaging stream that's generating those fake messages, and then we're writing it back out to S3 in a different location called sediment aggregations. So how does Lambda fit in here, right? So far we haven't really showed anything Lambda-based using AWS Lambda. We showed how you can use Kinesis to capture data, very easy to stream the data through Kinesis Analytics, aggregate that data. What we configured over here to do transformations, though, is this record preprocessor. So within Lambda, what you could do is before Kinesis Analytics analyzes your data sets, you could actually run your own custom logic, whatever logic you want, through Lambda. I happen to be doing some very rudimentary sediment analysis looking at the text. So the actual data actually doesn't have that sediment information. I'm enriching that data within the message before it hits the analytic within this Lambda function. You could very easily use this to be able to enrich it with other data sets, to be able to filter your data sets, transform your data sets into different names if you want to get it into a canonical form, that sort of thing. And what the output ends up looking like in S3 is a report that looks like this. This could have very easily been driving a real-time dashboard or various other applications, but we just pumped it back to Kinesis Firehose. Firehose does all the heavy lifting of storing all these files out to S3 for us, and now we have all these aggregations that we can do whatever we want with, really, within our application. So what we just showed is a couple pieces. The first was this, or towards the end was actually the Lambda preprocessing element. So what this is doing is actually taking the raw events where the raw event doesn't have any of the sediment information that we're just demonstrating, and the Lambda is actually enriching it before it hits that analytic. Once it hits that analytic, then we start doing those aggregations, that sliding window that you saw using SQL, just through some lines that look like this to be able to very easily write that real-time analytic and save those results out to S3. This is what the flow looks like. Actually, this is something we're going to be doing in a workshop on Thursday. So anyone who wants to come to the workshop, we're actually using this simulator and having folks get hands-on experience doing exactly that flow there. It's the Zombie Data Lake workshop. That was my shameless plug. But this is really what the flow was. So we had a simulator generate chats. It was getting transformed through Lambda, aggregations being done in SQL, and then data getting stored out to S3. And that entire flow that I just showed you, I didn't actually have to worry about servers at all. I didn't have to think about how many servers do I need to handle 1,000 records per second, 2,000 records per second. I'm really just writing those pieces of code you saw, and the serverless services are really scaling based on the amount of incoming data that's happening. I didn't really have to spin up any EC2 myself or anything like that. How does this really fit into existing real-time applications? Serverless is very, very powerful. We have many customers that will build complete serverless solutions using all the services that we just saw. But you could use different pieces of these and plug in other types of analytics and services within there. So it's very easy to use things like Kinesis streams and read the data off using the KCL, which is the Kinesis client library. You can read it off using Spark Streaming. So you can really mix and match a lot of these different services to be able to enrich existing pipelines that you have, but also use what makes sense for the use case and the solution that you're building. So what if we wanted to start doing some batch analytics, or interactive analytics, I should say? The first example that we're just looking at was actually real-time streaming data coming in. Maybe we want to start analyzing some data that already exists and is at rest on S3. And we're going to do that next. So what we're going to do is we're going to show how you could have large data sets on S3, how you could very easily discover that data. We're going to do a live discovery of the data during the next demonstration. We're going to start analyzing that data to be able to understand it better, and then start doing some Hadoop analytics off of it after that. So let's go ahead and switch over to that. One of the things I should also show just real quick is this here. On the real-time analytics that we're just showing, just to show you guys, in terms of how much scale we're pushing through, not massive scale. We have a lot of customers that are doing a lot more than this. But you'll notice, every minute, 50 to 70,000 records that are getting pushed through. It could scale much greater than that, but this is kind of actively running as I was demoing it. So let's do some interactive analytics on some of our data on S3. So to do that, I'm actually going to start with Glue. And within Glue, we're actually going to bring up the catalog. And the reason I like to show this is the Glue data catalog is relatively new. It went GA earlier this year, but it very nicely helps you describe your data on S3. So here we actually have a rides database already. You'll see the S3 location. Yeah, you see the different data types. This is Parquet data. If I remove this filter here, what we can see is a lot of different data sets. So here you see Redshift and Postgres and various data sets. But I have it filtered so it's only looking at a particular namespace or a database within the catalog called default. So let's go ahead and crawl a new location. And what I'm going to do is I'm going to actually select this crawler. And what these crawlers do is it runs within an IAM role. So you could very easily set up least privilege for these crawlers. It's all protected through IAM. But these crawlers are actually crawling my data on S3 now. None of this, this is all doing it live. And essentially what it's doing is it's crawling those data sources at this particular location. So I told it to crawl my serverless analytics data lake prefix location and put all of the new tables that it discovers. And remember, these aren't like real tables in a database. These are files on S3 that are doing a schema on redefinition of these tables. And it's putting it all into that default database or default namespace that we were just looking at a minute ago. So if we take a look over here now, a lot of those weren't shown. You didn't see a lot of those before a minute ago, right? It was just that rides database that was Parquet. And you'll notice, the last updated date, they're all right now because we just ran it. But you'll notice a lot of different things. It discovered JSON data, it discovered CSV data. So it discovers your data sets that you can then use very easily in your analytics. Just to show you an example, Twitter data, really fantastic data set to analyze and query against. But this Twitter data set, it discovered automatically for me. And the nice thing about what it did is it discovered these very complex JSON. So this is a very nested object. It contains array of structs of different array of structs. So the crawlers automatically discovered this entire DDL for me. I didn't have to go in there and pull out my hair trying to figure out what that create table statement would look like. The crawler ran it, discovered it. I could go in here and modify it and change different field types, different names. Maybe it discovered it as a numeric field and I want to treat it as a string. Because maybe it's flight data and there's no significant number difference between flight 100 and 1,000. So I might want to treat that as a string rather than a number. Because you wouldn't want to do like per carrier, the average flight number, that sort of thing. But it does a lot of that heavy lifting. So it really lets you bring in new data sets very, very quickly within your big data applications. So what we're going to do is we're actually going to look at a different data set here. We're going to look at this other data set that I just discovered called taxis. It's a delimited file. And what we can do is now we can start looking at the data. Everything that you're seeing is done kind of actively now. So we didn't have any of this data in Glue already. This data is just living in S3. And now we're starting to look at the data sets here. And the tool we're using now is Athena. So what we're doing is we're using the Glue data catalog, but you're using Athena to now query the data using SQL. So even though the data is CSV data, we're issuing select statements on top of the data set to be able to better understand that data. So let's do a couple queries here. This first query that we're going to run is just doing a count, a min amount, a max amount, and a count there. So let me switch this over here. So here this will take less than 2 seconds to run. We see it has over 10 million records. So if I actually tried to load this in Excel, it wouldn't load all the records, even though But the other thing that we start noticing is some anomalies in the data. So we did like a min total amount and a max total amount. I've never actually been paid close to $1,000 to ride a taxi in New York. It would be really great if I were. But you start seeing some anomalies in the data here as well. But this is ANSI SQL at this point. So what I could do is I could very easily join data sets together. I could start doing case statements. I could do all types of different things in here. In this example here, we're actually doing a case statement, renaming some vendor information. And you'll notice very, very consistent performance, scanning over the data, returning those records back. So this is actually New York City taxi data. This is 1 month of data. What if we want to analyze 8 years of the same data set? So 1 month was 10 million records. I'm actually going to query a different data set and do exactly that. So this is all 8 years of data here. And I'm actually going to query that group by year. And what I've done with this data set is the first data set was actually CSV. This other data set is actually Parquet, which is a column-oriented data set for query optimization. So I actually used Glue to transform the data from CSV to Parquet. And as soon as I do that, the responses are much, much quicker, both in Athena as well as some of the other stuff that we're going to show within Hadoop using things like Spark. And you'll notice, per year, about 400 million, 300 million different taxi rides. But what we could very easily do now is we could do a lot more complicated queries. So this next query is going to be looking at the average distance, the average cost per mile, the average cost, and the 99th percentile for 2016. And one of the things you'll notice here is within another second or two, less than 4 seconds here, it returned back the results. And the reason why it was so fast is we have the data really very optimized for a data lake in S3. So rather than keeping all the data in CSV, which is very non-performant when you're querying the data, we converted it to this optimized form, and it's very, very quick to be able to have our data scientists, our business users interact with our data lake on S3. So that was a little bit about how you can use the Glue data catalog to bring in your data sets, how you could discover your data, how you can start analyzing some of the data sets that you want to be able to bring in. And really how that fits in is really we're showing the part of this top flow. We didn't show QuickSight quite yet, but we're showing how you can have your data in S3. The Glue data catalog kind of sits over all these different services. It integrates with EMR, which we're going to show next. But then we were just demonstrating Amazon Athena here a moment ago. But you could really put these services together. So you could very easily have your real-time analytics using things like Kinesis Firehose. You could have your batch analytics or your interactive analytics using some of these other services, and put these services together to be able to have both real-time and batch analytics together. Out of curiosity, how many folks in the room are currently working on a data lake project? Awesome. Yeah, pretty good pretty good number. Data lake's very, very popular. Being able to bring in all these, both raw data as well as curated data sets, being able to expose those data sets securely through different sets of users based on different skills. You might have data scientists that want access to the raw data. You might have curated data sets for business users, that sort of thing. Where serverless fits in is we actually just demonstrated a lot of what is highlighted in the orange boxes there. So a very common data lake architecture on AWS, S3 as the central storage, being able to run a wide number of different analytics on that data, being able to categorize your data using services like Glue. But this is really where it fits in. Those 5 different services we just demonstrated very easily fits into that data lake architecture. Another view in terms of the data lake is really different users might have access to different levels of data. So your data scientists and your data engineers oftentimes are using various notebooks. It might be a Jupyter notebook. It might be a Zeppelin notebook. It might be different interfaces like RStudio. So really, different users might be interacting with this data on S3 different ways. But all of these services that you see listed up here integrate with that S3 central storage, integrates with that Glue data catalog off to the side to be able to have a central repository, central source of truth of all your data. So, but what about your existing Hadoop clusters? You might be running Hadoop, you might be running EMR, and you might be asking yourself, I want to leverage these things like the Glue data catalog or Kinesis Firehose, but how does it fit into my existing services I might be running today? So we're actually going to show that next here. So what I have running here is EMR cluster. EMR is our Elastic MapReduce, and I'll go ahead and bring it up here real quick. So we have this Elastic MapReduce cluster that's running, and very easy to spin up this cluster. I configured it to have Spark, Zeppelin, Hive, Tez, Presto, Hue on it, various applications out of the ecosystem. But what I also specified when I spun up this cluster is I want this cluster to actually use the Glue data catalog in order to be able to do things like run my queries against this cluster or run ML jobs using Spark ML, that sort of thing. So what we're going to do here next is we're going to show how you could use some of those tools. So I'm actually going to bring up Hue first. So Hue is a web interface to be able to have folks interact with your Hadoop cluster. So let me bring that up. I'm going to move it so you guys can see it. And so one of the things you'll notice right over here is this is a Hue interface. Let me make it bigger for folks in the back. And very easily what I could do is I could actually, you'll notice this rides database here. Default database only had rides in it. If I actually go back in here and I just requery this, one of the things you'll notice is all these new tables just showed up automatically for me, right? Even though I'm using Hadoop now and EMR, I could be writing all my jobs. I could be writing Hive jobs and all types of different things. I'm interacting with that Glue data catalog, and many of these new tables that we're showing right now are the ones we actually discovered through that crawling job we ran a moment ago. So in here, I could very easily write my jobs through this web interface. I could write them on the cluster themselves, that sort of thing. What I could also do is I could have my data scientists running on EMR using Zeppelin notebooks. So this is a Zeppelin notebook I have running here on top of that same cluster I just brought up. And you'll notice within here, I actually said show databases. These are all the different databases that are registered in Glue. And then down here, this is actually, I ran this earlier, but now if I run this again, you'll notice all those new tables show up for my data scientists that might be using Zeppelin notebooks as well. So all these different serverless services work really, really nicely with existing services that you might be using in your big data pipeline. So essentially what we just showed there is in that data lake, how can we use these other interfaces? So how can we use Zeppelin, Hue, Jupyter, still leverage the capabilities within the Hadoop cluster, but integrate it with the serverless data lake, the Glue data catalog, S3 as the central storage. So essentially, it's that thread through there that you see up on the screen. So essentially what we covered, and I can stick around for some questions here, is how some of these different serverless capabilities fit in to your big data pipeline. So things like Lambda being able to do event notification or event processing, event transformation, enrichment of your data. How you could very easily use things like Athena to be able to analyze and query your data sets, but still leverage the power of Hadoop and custom big data applications on top of EMR, all integrated with the same Glue data catalog and S3 repository. And it's really boiled down to leveraging these serverless capabilities so you could very, very quickly analyze your data and drive insights faster. It's all about that undifferentiated heavy lifting, so you could do that analytics. And of course, there's a really good cost savings in the terms of the pay-as-you-go model. So that was really the content we wanted to cover in this session. I'll stick around for some questions down here. I wanted to thank everyone for their time, and thank you.